Welcome. Today, we're going to demystify the command line. Seriously, we're going to take this thing that might seem a little intimidating and turn it into your most powerful tool for automation. We are talking about the bash shell.
I mean, think about it for a second. Renaming 100 files one by one, backing up your work every single night, pulling data from one place and putting it in another. All those boring, soul-crushing digital chores. What if you could just not do them anymore?
Well, you can. That is exactly what a bash script is. It's not some crazy, complex programming sorcery. It's literally just a recipe, a simple list of instructions that you write down one time and your computer will follow it perfectly forever. This is the absolute key to unlocking some serious productivity.
Okay, so here's our game plan. We'll start with the basics, understanding the shell itself. Then we'll write our very first script. After that, we'll make it flexible with variables, give it a brain using logic, and finally, we'll learn how to manage and debug our new creations. Let's do this. First up, let's get our bearings. We need to understand the environment we're working in, the shell. What is this thing really, and how do we even talk to it?
So there are basically two ways you can use bash. The first is what we call the interactive shell. That's when you're typing one command, hitting enter, seeing what happens, and then typing another. It's great for just exploring. But the second way, the non-interactive shell, is our recipe. It's a whole file full of commands that you run all at once. And that is where the real magic of automation happens.
All right, enough theory. It is time to stop talking about scripts and actually write one. We're going to start with the time-honored classic, the hello world. This is going to be your first real scripted conversation with the shell.
And you know what? The whole process is surprisingly simple. It's just 4 steps. First, you create an empty file. Second, you put your code inside it. Third, you tell the system, hey, this isn't just a text file, it's a program, which is what making it executable does. And finally, you run it. That's it. That's the entire life cycle.
And here's the code itself. Super simple, right? That first line, the one with the hash and the exclamation point, that's called a shebang, and it's really important. It's a special memo to the operating system that says, hey, when you run this file, use the bash program to do it. After that, it's just one command, echo hello world, which, you guessed it, just prints hello world right on your screen.
Okay, so a script that says hello world is a great first step. But a script that can say hello to anyone? Now that's a game changer. Let's make our scripts way more flexible using variables and even some user input.
So what's a variable? Honestly, just think of it like a box with a label on it. It's a container. In this case, we have a box with the label who's variable. And inside that box, we've put the text world. The cool part is, later on, we can just refer to the label and the script automatically knows to use whatever's inside the box.
And we can even let a user fill that box for us. Check this out. This script first asks a question. Then that read command just pauses. It waits for you to type something and hit enter. Whatever you type gets popped into that name variable. And then it uses that variable to greet you personally. How cool is that? Our script is now interactive.
Now listen up, because this next part is super important and trips up a lot of people. The type of quotes you use in bash really matters. Double quotes are kind of weak. They let bash peek inside and replace any variables with their values. That's how we get hello world. But single quotes, they're strong. They tell bash to treat every single character inside them literally. No peeking. That's why you get the $sign and the word world printed out. Remember that difference. It's going to save you a lot of headaches.
So our scripts can store information and they can talk to us. The next big step is to give them a brain. Let's teach them how to make decisions based on logic.
And the key to all of this is the test command, although you'll almost always see it written as just a set of square brackets. This is the absolute foundation of logic in bash. It lets your script ask a question, like, is this number bigger than that one? Or hey, does this file even exist? And it gets back a simple true or false answer.
And with this simple tool, our scripts can start asking some really powerful questions. We can check if 2 pieces of text are identical. We can do math comparisons, like seeing if one number is greater than another. We can even check things about the computer itself, like verifying that a file is actually a directory. This is how you build smart scripts that can adapt and react to different situations.
All right, for our final section, we're going to level up with 2 essential skills for really mastering the shell. How to manage your scripts when they're running, and, this is a big one, how to play detective when they don't work.
So sometimes you'll have a script that needs to run for a long time. You don't want to just sit there staring at a blinking cursor, right? Well, if you add that little ampersand at the end of the command, you tell the shell to run it in the background. It frees up your terminal so you can keep on working. And you can manage these background tasks with commands like jobs, fg, and bg. It's like multitasking for the command line.
Okay, let's talk about something everyone deals with. Errors. Bugs. Here's a script with a problem. We're trying to tell the computer to add the number 5 to the letter S. That doesn't make any mathematical sense. The computer is not going to like that. And sure enough, when we run it, we get an error. It says non-integer argument. And, okay, we kind of know what that means. But imagine this error was buried in a script that's hundreds of lines long. The error message doesn't tell us where the problem is.
But check this out. This is where the debugger becomes your absolute best friend. If we run the script using bash x, it turns on this special debug mode. Look at that output. The lines with the plus signs show us exactly what the shell is doing, step by step. It prints ++ express 5 plus ses, and suddenly the problem is completely obvious. We literally told it to add 5 to s. The debugger turns a mystery into a simple fix.
So, let's just wrap this up. We've gone on a whole journey here. We started with a simple hello world. We learned how to make our scripts flexible with variables. We added a brain with decision-making logic. And we even learned how to find and fix our own mistakes. These are the foundational building blocks you need for automation. But here's the thing. The real power doesn't come from just knowing this stuff. It comes from applying it. So I want you to think right now, what's that one boring, repetitive thing you do in your computer all the time? That's your first target. Go build a script for it. Start automating.